This video clip will explain how to rearrange formulas to highlight a quantity of interest. For example, PV equals nRT is an equation that is used in physics and chemistry. P is pressure, V is volume, the size of like a gas, like in a balloon or something. T is temperature, R is 8.31, N has to do with the number of molecules. So pressure times the volume equals the number of molecules times the temperature, more or less. So if we wanted to know what would happen to the volume as temperature changes, we would want to isolate the V or rearrange this equation so that the V is all by itself. So if we wanted to do the opposite of multiply by P, we would divide by P. Whatever we do on the left, we have to do on the right. So P divided by P is 1. So V equals nRT over P. So that says that if the pressure and number of molecules stay the same and the temperature goes up, then the volume would also have to go up because they are equal. If the right side of the equation gets larger, the left side of the equation also has to get larger by the same amount. So that's the reason that you would rearrange an equation if you want to study volume, for example. Or we could change the pressure. So what would happen to the volume if we change the pressure? Let's say pressure goes down. So like if we divide by a smaller number, pressure goes down, gets smaller, then volume would have to go up. An example would be 8 divided by 4 is 2, but if I divide 8 by a smaller number, like 2, then 8 divided by 2 is 4. So if I divide by a smaller number, then I get a larger number. So pressure goes down, the volume goes up. Like if you put it in a balloon in a vacuum chamber, the pressure around it would go down, so it would grow in size. So let's solve for P. If we want to investigate pressure, I want to get the PL by itself. So we get rid of the V by dividing by V. So the pressure is equal to nRT over V. So the P times V, the opposite of multiply by V, is divide by V. So when temperature goes up and the volume does not change, like in a closed container, a metal can or something, what would happen to the pressure? Well, if the temperature goes up, then the pressure also has to go up because there's an equal sign in the equation that says the right side is equal to the left side. Here's another example. The frequency of a pipe instrument is equal to, the F is the frequency, V is the speed of sound, velocity of sound, L is the length of the pipe. So F equals V over 2L is an equation that you could use to create a musical instrument. If you want to know what length to cut the pipes, then you want the L all by itself. Right now it's in the denominator, so to get it out of the denominator we need to do the opposite of divide. So the frequency equals the velocity over 2 times the length. Let's multiply each side by the length. Length divided by length is 1. 1 times anything doesn't change it, so let's just get rid of them. So the length times the frequency is equal to the velocity, half the velocity. Well, we wanted to get the length all by itself. We wanted to get rid of the frequency. Length times frequency, well, the opposite of times frequency is divide by frequency. We already have our divide symbol there, so let's just put the frequency underneath it. So the length of the pipe can be calculated by taking the velocity, the speed of sound in air, which is about 343 meters per second, divided by 2 times the frequency. So you would look up the note C, you would look up the frequency of that note if you wanted a pipe that would play that note, and that will tell you the frequency. Multiply by 2, divide the velocity, the speed of sound in air by that, and you can know what length to cut the pipe. Another equation is for the period of a pendulum. So like on a grandfather clock, they have a long swinging arm. T is the time that it takes to swing back and forth. L is the length of that, and G is the gravitational pull. On Earth, it's about 10. Well, if we want to know what length that needs to be to have it swing back and forth once every second, for example, then we would need to solve that equation for L. So let's get rid of the 2 and pi times what's in the square root sign. The opposite of multiply is divide. Whatever we do to the right, we have to do to the left side, so they will still be equal. Pi divided by pi is 1. 2 divided by 2 is 1. So the square root of the length over gravity is equal to the period over 2 pi. Well, to get rid of the square root sign, we need to do the opposite of square root. The opposite of square root is square. Whatever we do to the right, we have to do to the left. The square root and the square signs cancel each other, so we just have L divided by G, gravity, is equal to T over 2 pi squared. We want the L all by itself. It's being divided by gravity, so we're going to multiply by gravity. G divided by G is 1. So if I wanted to find a length for a specific time in Earth's gravity, I could just plug in the time that I want, put 10 for the gravity, and calculate that on a calculator.